Now as I have told you, there is two type of bond formation, ionic and covalent. So in ionic it is formed between metal and non-metal, one lose electron, another gain electron, right. Now we will be doing for covalent bonding. So in covalent, mutual sharing of electron take place, mutual sharing of electrons take place. And how now you can judge that these atoms will contain the covalent bond? Just write, like if I say HCl. So if I tell you to make bond between hydrogen and chlorine, write hydrogen, write chlorine, write their atomic number, write their configuration. Now you will see it also need an electron to complete its octet, and it also need an electron to complete its octet, and one means it is non-metal, again it is non-metal. So whenever the bond is formed between non-metal and non-metal, it is always covalent. Metal and non-metal ionic, non-metal and non-metal always covalent. Now how it is formed? I am taking an example for you. Suppose we take a bond formation between hydrogen and chlorine. Same we will be doing, I am doing here only, just look at the board this side. So hydrogen has 1 electron and chlorine has 7 electrons. So what they will do, they will mutually share electrons, means chlorine will share this hydrogen electron, and hydrogen also needs a 1 electron, it will also share its 1 electron. So after doing it, it will complete its duplet and it will complete its octet. So that means 1 electron and 1 electron is being shared, so there is 1 electron pair. So it is called as single covalent bond. So this is how the bond is formed. Similarly, we are taking up an example of say the double covalent bond in which 2 electrons are contributed. For example, I take oxygen molecule. If I tell you to make a bond formation between oxygen molecule, what you will do, you will see O2, okay, O and O. Then write their atomic numbers, write their configuration, non-metal, again non-metal, that means covalent bond. So we have to start with both of them simultaneously, write O, write O. So how many electrons they need? You have to put those much electrons in the middle, because then only we'll be able to make an electron cloud. So 6, and it also needs 2 electrons. So we are putting 2, 4 and 6. These are the already electrons it already has. And similarly for this, I am indicating with the crosses just to make it clear, so that you should know that these electrons, dotted one belongs to this atom and this cross one belongs to this atom. Now they will mutually share like this, and it will also mutually share like this. So that means there is 2 electron which is being shared. So this is called as double covalent bond. Similarly, we can make a bond for nitrogen to show a triple covalent bonding. It happens in many molecules, but for your sake I am taking a simple molecule, so that you should know first how to make bond formation between the similar ones, so that you can easily make the bond between the dissimilar ones. It is the same way it happens, okay. So nitrogen N 7 atomic number, configuration 2 5 2 5, it needs 3 electrons. So we will put 3 in middle and 2. These are the already electrons which it already has, like this. So this nitrogen will share these 3 electrons and this will share these 3. So there are 3 electron pairs. So bond form is triple covalent bond. So this is how the bond formation, the covalent bond formation can be shown by just drawing the electron clouds. You need to draw this electron clouds. If you are not drawing it, then it is totally wrong way of representing. Just drawing a line is not correct. Whenever you are showing the bond formation, you have to draw these electron clouds. Now taking into account few more examples between dissimilar atoms, so that you should know, because these were the simple ones comprising of only 2 atoms. I want you to know that how for many atoms you can make it. Like if I am telling you to make it for CH4, just first write C and H, again the same steps I have told you, atomic number 6, 1, configuration 2, 4, 1, non-metal, covalent bond. Now how you will arrange them? CH4 means 1 C right in middle, surrounded by 4 hydrogen. So surround it with 4 hydrogens. Each hydrogen has 1 electron and carbon has 4, but carbon cannot be partial. It has to equally contribute electron towards all the atoms. So It distributes all electrons like this in the same manner, equal number of electrons towards all hydrogens. Now this hydrogen will share this electron and get stable. It completes its duplet. Similarly this, and similarly this. Now all hydrogens are stable. Now how carbon will become stable? It already has its own 4 and it will accept those 4 ones of hydrogen as well. So this is the bond formation. See, single bond, single bond, single bond, single bond. So this is the geometry of CH. In later classes, higher classes, you will be knowing that instead of drawing hydrogens like this, we draw hydrogen like this. The reason being because there are so many electrons which are surrounding the central atom, there are certain kind of repulsions also. Those repulsions just distort the geometry. It no longer remain as such, it get distorted due to repulsions. This will be taking up in the 11th standard or in higher class, you will be knowing that, but for this movement you should know, draw the bond like this, but try to remember the geometry like this, and the name for the geometry is tetrahedral. Right. Similarly, we can do it for CCl4 the same way, C and surrounded by 4Cl. And if you wish to do for water, how you will do for water? So oxygen in center surrounded by 2 hydrogen atom, again it also has repulsion, so therefore the geometry is distorted. You can't make it this way because it has certain kind of repulsion which distort the geometry. So just try to remember that, put oxygen here and hydrogen on this side and this side. Again we know oxygen 8, hydrogen 1, 2, 6 and 1. So 6 means each hydrogen needs 1, each hydrogen has its own 1 electron and needs 1. So oxygen has to put 1 electron towards these hydrogen, and the leftover is just dotted around. So that means 6 minus 2, it is left with 4. I am putting 1 pair here and 1 pair here. This hydrogen is getting stable by sharing the oxygen electron and even this, and so that means, and this oxygen 4, 5, 6 and 2 of these hydrogen. So this is the bond. So see, single bond, single bond. So there is not always compulsory that all the electrons which are surrounding the central atom will participate in bond formation. The electrons which participate in bond formation are called as bond pairs, and the electrons which do not participate in bond formation, as I have shown this, they are called as lone pairs. So there are actually the repulsions between the bond pair or bond pair lone pair or lone pair, because you can say there are bond pairs also, there are lone pairs also, and there are lone pair and bond pair also. So due to presence of different types of electrons, different types of electron pairs, there are repulsions. That is why the geometry get distorted and it comes out to be, and the name given to the special geometry is bent geometry. This you will be doing in +1, but for the sake of conveyance, as we are covering this topic, so I want you to know the name of the geometry, because it will hardly take a minute to remember the name, and when you will go in higher class it will be easy for you because you will be already familiar with the name, what is this bent. So this is just due to the repulsions between the electron pair that the geometry is getting distorted.